Hello friends, I am Amirano Nizami and today we are going to see the Python scripting to obtain plots from the Abaqus. So one of my students, he asked me regarding this Python scripting that how to get the results from Abaqus, because sometimes we know that when we have very fine machine, so it takes a lot of time to get the results, and also it is difficult to extract the plots from there. Okay, it's not too easy. But if we use some Python scripting, as here in this images, we can see here that this is my Abaqus file, and and then I have written a Python scripting here in this way, and then just using the command directory, I run that file, and I am getting the plots here. Okay, results here. So in that way, let's see how we obtain that. So just a minute, I will show you the file here. So this is my Abaqus CAE file, and where we are just seeing this. I ran the code Abaqus file, and then I got this results. Okay, so basically this is the U3 directional, and it is three-dimensional solutions for the anti-symmetric cross-ply four-layer cross-ply laminate. Okay, so when I got this results, so it was taking time to run this file. So what I did, I just used that CMD command. So I will show you how to use that. So right now I am just cutting this, which I already used. So let's go to the file where it is. So here my file is there where I am having that. I will just go here and just click CMD command directory and just enter here. Okay, it's very simple. I will write Abaqus and then Python and the code, Python code, which I have written to obtain the results. So I want the displacement results from Python. So I am having the code here for the displacements. This is for the stress. Let's see for the displacement where I'm having. So I'm having this. So I will just copy it and I will just paste here. So I will just paste here and I will give the extension py.py. That's the Python scripting. And I will say enter. Now we will see this is running and we can see the results here. Okay, so we can see the in-plane displacements. It is showing u1 for the anti-symmetric four-layer cross-ply plates. Okay, so it is very easy to see this. Okay, and also the next plot, let's see, it is u2. Okay, so we can see the next plot u2, that is there, and now we will see the displacements u3. So we may see the u3 displacements. Okay, so this is very easy. It becomes very easy once we write the Python scripting. So we will just see the Python script also where we have written that. So let me show you. So this is my Python script. Okay, so this is first we write the ODB file. Okay, and we give that where we have stored directory. Okay, and then the job name. What is my job name? Okay, so I may show you the job name here. So when I ran this, we will go to job and we can see this is my job name, job for anti-symmetric cross-ply. Okay, so when I got this job name, I just copy and I'll just keep it here. Okay, I just pasted here, so the job name is there. Okay, so in the same way, here in this script where I have written ODB file, I have given the job name here. Okay, for the job, and the extension is .odb. Okay, and then I've just given the length of the plate 1200 mm. I am taking a square plate and width also 1200 mm, and the thickness of the plate I am taking 300 mm. So A by H ratio, if you will calculate, A means L, length by thickness ratio is equals to 4. Then it is very thick plate. Okay, so when it is very thick plate, so I am getting the exact three-dimensional solution using the finite element method, and then we may compare it by using our own 3D code. Okay, using the Pagano's solution like that, and then we can see the results. Okay, so I've just prepared that, and I thought, okay, to plot that along the z coordinates, along the thickness direction, I have just compared. So I just extracted u1 values, u2 values, and u3 values. Okay, that is UVW. Okay, u1, u2, u3, these displacements. So I just extracted those. Okay, and the coordinate where we want to extract x minus x dash, similarly y minus b by 2. Wherever we want to extract that, we can extract the results, and then just calling those results, and we will just plot here. So a very basic and very simple way to find this. So the same way I just did it, and I showed here. Okay, so we have visualized the results also. This is for the U3. Similarly, we can have U1. So if we rotate this U1, we may see it because it is anti-symmetric, so it may not be symmetry above and below, because we know that 0, 90, 0, 90. It is anti-symmetric about the mid plane. Okay, so this is the results we are getting. Okay, so this is for the U1. Okay, and similarly we will get U2. So but U2 is in this direction. Now it is like this. Okay, so thank you.